we will continue on module 01 recapitulation of C. In the this is the third part. In the first two parts we have talked about the data types, variables, expressions, statements, and in the second part we have talked about different derived types, arrays, structure, union and pointer. In this part we will start with the basic modular concept of C, which is functions. So, as you all know, a function performs a specific task of computation. So, a function is like can be treated as a black box, which can take a number of parameters and will give you a result. Now, while usually we will expect a function to take one or more parameters, it is possible that you write a function which does not take any parameter, and it is typical that it gives you a value at the end of computation. We say it returns a result, but it is also possible that it may not return any result. So, the number of parameters that a function has, each parameter also called argument, will have a type, and if we do not want to specify the type, we can use void. Return will also have a type, and we will use void if there is nothing to return. A typical declaration will look like this: funct is a name of the function, on the left is the return type, and on the right within this pair of parentheses you have the parameters. If there are more than one parameter, they are separated by comma, and at the end of this parenthesis if you put a semicolon, then we know that you are just interested to talk about what parameters the function take and what type of value it returns, but you are not interested to specify how actually this funct function computes the result integer from the parameters x and y. So, in such cases, if we just terminate the list of arguments with a semicolon, we will say this is a function header or a function prototype or a function signature. And more the signature or prototype kind of terms will keep on occurring in C++. And since in this case, in case of a signature, we are not actually specifying how x and y will be used to compute the result, it is optional whether you specify x or y or both of them. You could just write it as int funct parenthesis open int comma int parenthesis close semicolon. That will also be a valid header. So, what this tells us? It tells us that there are two parameters. First parameter is an integer, second parameter is another integer. It tells that the name of the function is funct. It tells us that the type of value it will return is int. This is the purpose of the function declaration or the function header. Now, when we are ready to specify as to what this function will compute or how this function will compute the result from the parameters, then we provide the function body, which is the whole function body is a compound statement. So, it is a pair of parenthesis, curly braces, within which the function body has to be written. So, within that there could be multiple declarations and statements specifying the function body. A function will have a return statement which returns an expression of the return type as a final result. If the function is not returning anything, if the function return type is void, then the return statement will not have an expression associated with it. Please note that in C89 it was allowed that if a function does not return anything, then it is not necessary to specify the return statement. That protocol still continues, but for several reasons that will become clear when we do more of C++, it is strictly avoidable that you write a function and do not put a return. So, even though you may not return anything from the function, that is return type is void, please provide a return statement. Now, functions get their parameters by a mechanism which is known as call by value. I assume that you all know this, where at the call site the example is here. On top you can see the function body, the whole definition of the function, and here you see the function invocation or function call, where we are using two parameters that are local to, that are variables local to main, to call this function. So, the result of this, the first parameter a is copied to the first formal parameter x. So, a, b are called actual parameters at the call site, x, y are called the formal parameters at the definition site. And as I had mentioned in reference to accessing different components of an array and accessing different components of a structure, that there are different conventions. Here C follows a positional parameter convention to call function. So, the first actual parameter corresponds to the first formal parameter, the second actual parameter corresponds to the second actual formal parameter, and so on. So, you do not care about the name of the formal parameter at all. The actual parameter value is copied from one parameter to the next, and then it is used in the function. Since these are copies, so they have separate memory locations. So, after when funct starts executing, x will have a location different from a, but since the value has been copied, the value of a is 5, value of x also to start with will be 5, but then within the funct body we have made changes to x and y. We have incremented x, incremented y, we have computed the return value. So, when the function returns, that is when this value, return value x plus y is computed and given back to the caller main, and that value is copied to z, when that happens, then we lose the values of the formal parameters x and y. Interestingly, a and b, which are actual parameters, they will not change even though x and y had changed, and it is very easy to see. In call by value, you are using separate locations. You just at the beginning you had copied the values. So, since you had copied the values at the beginning, they are different locations. So, when you lose x and y, all the changes you had made to x or to y or to both only simply gets lost. The actual parameters are not affected. So, just to illustrate that, we are printing the values of a and b here, and we find that they are as original, they are still 5 and 10, even though x and y, the copied values, had changed. Which is not very common, particularly to the C programmers, is the notion that the mechanism by which you return the value is called a return by value mechanism, and it is not explicitly mentioned in C, because there is no other way to return, to put it straight. I mean, in C, the only way to return is by copying the value back, because at this point the function funct which was executing is will get terminated after giving you the value. So, there is no other way than to keep a copy of that value which we have assigned to z here to get that value back. As we go to C++, we will see a different mechanism both for call by value as well as for return by value, which will be very, very powerful. Functions can be recursive. I am sure you all have seen this. You all have seen factorial functions like this, or the very famous Fibonacci function, which uses 2 recursive calls. You have seen merge sort, you have seen quick sort. These are all very typical examples of recursive functions. Any recursive function will have a recursive step and one or more exit condition to end the recursion. Here is another example which is less commonly used. So, I just put it here for illustration. Here given a unsigned integer n, this recursive function computes the number of ones in the binary representation of n. You just go through this carefully and just familiarize itself with the recursion mechanism. Functions and pointers can be mixed in a very interesting way, and this is again one of the very powerful features of C. Before highlighting what we want to specify for the C language as such, let us just briefly understand this example, because this is an explanation by example. So, what you are showing at the top are the situation is like this, that we have a collection of geometric objects. The geometric objects could be circle, rectangles or triangles, we assume that the triangles to be right angled triangles which are aligned with the axis. So, we have structure for each one of them. So, a circle is x y, that is the center and the radius, a rectangle is x y, that is say left bottom corner, width and height, and a triangle is x y, which is the right angled corner, the base and the height. And here we make a structure, again this is a typical way to write in C, we make a union of all these, because a geometric object is any one of them, and given a particular geo object, it could be either a circle or a rectangle or a triangle. Now, how do I know which one is done? So, for that, in this structure we are using another enumerated value G code, which keeps one of the codes of SIR, REC or TRG. So, the idea is, if you have put in this union, if you have put the structure for a circle, you set G code to CIR, which is 0. If you have put in this union the structure for a rectangle, then you put G code as REC and so on. So, this is a typical use. So, you can see that we have a union of structures, and then you have a structure containing that union and a indexing code to understand what that union has. And if you in C programming, this was a very common paradigm to do, and we will use this example later on in C++, as I said, in the context of inheritance, and show that how in C++ this can be done lot more efficiently. Now, the situation is, since these are 3 different types of geometric objects and my task is to draw them on the screen. So, I have now the way you draw a circle and the way you draw a rectangle and the way you draw a right angle triangle are all different. So, naturally one code cannot be written, one function cannot be written which can draw all 3 of them. So, we assume that there are 3 different functions. In C, all of them are actually drawing, but in C certainly we cannot have 2 functions having the same name. So, I call them as draw circle, draw rectangle, draw triangle. Now, each one of them takes the same structure geo object. For example, if we look into draw circle, then it takes the geo object, and in the geo object it will be able to find out that it indeed is a circle if it checks for the G code, and it will print all these values. Here actually this in the real draw function, the print will not be there, there will be graphics function calls to actually draw the circle, but just to illustrate the point I am showing here through print. So, these are the 3 different functions which can draw 3 different types of geometric objects that exist. Now, we want to write a routine, the main function, which given the G code of any of these objects and the structural parameters of that object, should be able to draw it. So, the idea is, I would like to call the draw function, any of these draw functions, not using their name, but from the fact that if my G code is CIR and I want to call the draw, this draw should get called. But if my G code is REC and I want to call this draw REC should get called, and so on. So, we want to make the call uniform, so that I do not really need to know what particular object I have at this point of time. What object I have is already a part of the object structure, because I have a G code, and then it should be possible that the corresponding function will get called. So, the mechanism that is done here is I create an array called draw function and put all these function names. As you put these function names, these are called function pointers. A function name used by itself without the pair of parentheses, the pair of parentheses as we will see are called function operators, which tell you that the function is being invoked. Here those operators are not used. So, these are just the function names, they are the function pointers, or in other words, these are the addresses where the respective functions start. So, this is an array draw draw ARR is an array of these function pointers. And what will we see? That the 0th entry in this is draw CIR, which is drawing the circle. So, if the G code is 0, that is CIR, and then if I access this array with that G code, so GO dot G code is CIR here, which is 0, which means the 0th function pointer. So, the value of draw ARR GO dot G code turns out to be draw CIR. Whereas, if I put GO dot G code as rect, if it is a rectangle structure, then GO dot G code here is 1. After 0, this is 1, which means in the array I am accessing location 1. So, this particular function becomes draw rect function, and so on. So, the notation is little bit not so common. So, you do not see the typical function like name, but you basically it looks like an array element, which is the pointer, and but when you get the pair of parentheses, you know that there is a function operator which invokes the function that you have accessed from this array. Now, to be able to create a function pointer or array of function pointers, what does the array need? Array needs all elements must be of the same type. So, all these function pointers must be of the same type, which means that they must take the same type of parameters and must return the same type of value. So, we ensure that by creating a type or aliasing a type draw func here by type def, which says that it takes a structure geo object and returns a void. We want to say that this is a pointer type, that is why the name is not draw func, the name is given as star draw func. The way if we have to define an integer pointer, we say int star p. So, basically the name is not p, name is as if you are saying that the star p is an integer. So, here what you are saying is star draw func is a function which takes a geo object, gives a void. And now, if you look into all these 3 candidate functions, all of them have that same signature. So, they have the uniform signature. So, they are all of this draw func type, which is a pointer to a function taking a structure struct geo object and returning nothing. So, this is a typical use of the function pointers, a very powerful mechanism in C. If you all the graphic systems, the menus, everything use this concept of function pointers, and as we go to C++, we will show that how C++ has significantly improved this and made it easier and more robust to use in terms of what is known as a virtual function table. That will come when we discuss that. Finally, to close the discourse on C programming language, you know there are input output functions available in the stdio.h. These are most common are printf and scanf, which use format strings. It uses also another interesting part of C programming known as ellipses, or these are known as variadic functions, given that you do not know how many parameters you will put in printf. So, whoever wrote the code of printf did not know whether you want to print 5 values or 10 values or 1 value. So, a typical format based structure has been created. I will not go into depth of that. We will cross that when we come to dealing with discussing IOs in C++ to contrast how C++ avoids variadic input output functions, but these are the typical ways to do input output in C, which I am sure all of you are very familiar with. These are examples showing you how to do the input output with files. So, you use a file pointer, you do fopen to open that and so on. Now, we will move on to just mention that if you just had the C language, then you could not have written any program, because you saw the first program which we discussed in the first part of this module. Hello world program needed a printf, and it is not easy to write a printf. So, to be able to effectively use a programming language, you need a basic library to be available, and any language specifies what is a library which every compiler must provide, and that library is known as a standard library. That library has all the function names, the header names, and all of them fixed by the language design. So, C has a standard library, as we will see as we move to C++, we will see that C++ has a much stronger standard library, but C standard library also is quite powerful, and interestingly whole of the C standard library is also available in C++. So, it is not that in C++ things will get replaced, only new things will get added. Now, C standard library has many components, every component comes under one header file, and there are, you can look up the total list, but I have just put in the 5 which are most frequently used: the input output header, the standard library header which has a mix of things to do memory allocation, conversion, searching, sorting, so on, the string for manipulating C strings, the math library, all different kinds of common mathematical functions, and the error header which deals with the error, different error numbers and error ranges and so on. So, please familiarize yourself more with the standard library, and I would suggest that whenever you are using some standard library component, please look up the manual to see what all other functions that component has, and it might so happen that in many places you are writing certain functions for doing a task which is already available in the standard library. At the end, I should also mention that a C program needs to be properly organized, and it is good to separate between header files and source files, as I say, like the way the library is organized. In the, when you include stdio.h, you are actually including the function prototypes or function headers, the implementations are given somewhere else. So, when you make use of certain write some functions of your own, you should also separate them in terms of header and the files that implement those functions. So, in your program you will typically have two kinds of header files, the header files that you have written and the header files that the has come from the standard library. So, the header files that comes from the standard library or system header files must be specified with these kind of angular brackets, and the header files written by you must be within double quotes. We will explain the reason for this more when we go deeper into C++. This basically tells the system as to where to look for this file, whether to look for them in system directories or to look for them in your current work directory. So, this is a typical example. I am just trying to deal with an application that needs quadratic equations to be solved. So, there will be several contexts of why you need to solve the quadratic equation. It could be computing interest, it could be solving some bridge equations, whatever. So, this is the application program which assumes that you have a quadratic equation solver. So, you are implementing that. So, you have one header file solver.h which gives the interface of that function or the prototype of the function with all different parameters. You have another where you put the code of this function or the implementation of the function body. So, you call this solver.h, you call this solver.c. Solver.h has all the details. So, here formal parameters have name, here formal parameters do not have name, they are just types given. And in the application, you just need to know the header, you do not need to know how the quadratic equation is solved. All that you need to know is in the signature it has 5 parameters, first 3 of them are the 3 coefficients of the quadratic equation, and the next 2 are 2 pointers or 2 address locations where the 2 parts of the result needs to be stored in case the quadratic equation is solved with a complex value result. So, you will need the real and imaginary part to be stored. So, you just need to know this information to be able to write the application. So, your application file includes solver.h, just the header. Your implementation of the quadratic equation solver also includes solver.h, which makes sure that between this solver and your application the same header is included. So, there is no chance of a mistake. So, you should always separate this out, that headers which are common functions, macros, constants, manifest constants, that are to be shared between different source files. Then for every function or for group of functions, you have separate implementation files which will include the same header, and this application files will only include the headers and will not need the implementation files to be referred. So, please follow this organization and we will see more of that as we go to C++. In a typical situation, this is how you prepare your code for execution. You start with a source code which could be C or C++. Then as you compile, you may compile through an IDE, just say build or compile, something like that, or you could do it through a text based interface like you say G++ or some C++, something like that. This is the process stages that happen, and this is just the outline. We will discuss more as we go into the C++ stages. Your source file first goes through C preprocessor, which takes care of hash include, hash define, this kind of preprocessor directives. Then it gets compiled into some kind of a low level language known as assembly language. You see those files as .s or maybe some other systems will have different kinds of file name extensions. Then you assemble them to generate the object files which are called .o or .obj, and there could be several other object files that come from your libraries, like if you have included stdio.h, then that stdio.h gets included at this stage, but the actual implementation is not available. So, that has already been compiled through this process separately, and a .o file has been created, and that .o file is getting, as we say, linked to your program. If you are using an IDE, you will not be able to see this explicitly, because IDE sets it up for you. If you are doing it from the command line, you will have to actually use -l and include that standard library, and all of these together will give you the executable code. As we go more into C++, we will see that how the build process also impacts the C++ programming and the different programming features. In terms of tools, there are multiple IDEs available, like CodeBlock, there is Visual Studio, there is Eclipse. So, we will advise that you use some IDE which is open source, typically CodeBlock or Eclipse, and whatever IDE you are using, you specify that these are the standards, like C99 is a standard that you are using. Otherwise, the behavior of the programs that as we show them, and the behavior of the programs as you will experience in the IDE will be different. So, always use, for C you use C99, for C++ we will use C++ 98, or we will see in some context we will use C++ 03, we will come to that. These are the reference books in case you want to refer to. And so, in summary, in this whole module we have achieved this. We have revised the concepts of fundamental concepts in C, variables, data types, literals, control constructs, and we have iterated through functions and pointers and the organization and the build process. So, I would expect that this will give a quick recap to your fundamentals in C, and if you have found certain points that you did not understand well, or the examples were not well absorbed, then please go over them again or ask questions to us on the blog. But with this module, we will expect that this is the level of C that you are prepared with to be able to proceed with the C++ language training. So, we will close module 1 here. In module 2 onwards, we will start showing you how in C++ some of the common examples that we have seen here, or some of the other common examples in C, can be done more efficiently, effectively, and in a more robust manner in C++.